So the footprint is actually okay. The footprint is actually a recording, okay, of the temperature and the conveyor speed fluctuation, okay, in the reflow oven. So the footprint is actually. Can you hear me? I think there's a echo. Okay. So what it does, right, is that it measures, okay, it records, it captures the temperature fluctuation in the reflow oven. So when that's abnormal fluctuation, you're able to observe them. Okay. So what exactly is when we put the footprint into the RPI or the probe, right? Okay, so as you know that the RPI or the probe, right, it generates a profile, okay, for every board. Okay, every board that's going into the reflow oven and then it comes out, we generate a profile for that. And then we have the troubleshooting to actually tell you, okay, what is the maximum deviation, okay, in the reflow oven, okay, for that particular board. So what does the footprint do, okay, to value add the RPI system? So, you know, when we take the profile of every board, right, we are able to know the temperature of the board, okay, but we are not able to know, you know, what is the fluctuation, okay, in the oven, like intermittent fluctuation. That means to say the fluctuation might happen in a while, or it might happen occur somewhere in between, okay, the profiles. Okay, so when we introduce the footprint, right, we are trying to capture, okay, the live like the recording, okay, of the temperature fluctuation in the oven. So what is the objective of the footprint? It's actually to okay, to capture, okay, real-time temperature and conveyor speed fluctuation, okay. And number two, which is the more important one, is to measure, okay, to monitor the drift of the temperature and detect any abnormal condition. Okay, that means to say where temperature suddenly fluctuate very big, okay, when you load, let's say you load a different model, okay, or when you load, you overload, okay, the oven, or when there's something wrong in the oven, okay, we are able to capture that, okay. So what are the benefits of the footprint, right? Okay, it automatically records, okay, the fluctuation, okay, when the VP is running. Okay, you know, the VP generates the board for the profile for every board. So on top of that, we are using the footprint to actually measure, okay, the fluctuation, the temperature fluctuation. So whenever there is a profile that's out of spec, okay, we are able to see, okay, to view the temperature fluctuation. So unlike the troubleshooting, right? Troubleshooting, you're only getting a picture, an image of the maximum deviation. But you know, you do not know where is how long is this deviation
Dennis,
occurring.
I want to stop you in between because there may be questions in many mind. You are saying it is recording the fluctuations. Right. So RPA was also doing the recording of the fluctuation in terms of taking readings, maybe 4 readings in a second or something. So correct. It is just a manipulation of those data through some software, or you're doing something differently to capture this temperature. Because we are doing anyway the temperature recording 4 times in a second.
Correct. We are recording 4 times in a second. Okay, and then what we record is the profile, you know, the profile graph. So right now you do not have something that you can see, you know, the actual moving of the temperature. You know, I mean, we capture it every 4 seconds, okay, but then we make it into like a video, okay, where we record, okay, the actual, you know, the fluctuation of the probes in the oven. So let's say that you know, let's give it an example. Let's say the blower fan, sometimes it's working, sometimes it's not working. So when sometimes it's working, it will show a good fluctuation. Then sometimes if it stops maybe for a few seconds, then maybe we will see a drop in the temperature. and then after that you see it resume back. So this is something that you can capture from the footprint itself. Okay, it might not cause an issue for your profile.
You mean to say you're using the same data and using the data which recorded by RPI, you're using the same temperatures, but you're converting into video form so that you can see the live video kind of a thing. So how the temperature moving in a curve. So we know exactly what is happening.
Right. So it is we are capturing the key probe data, the probe, the probe sensors that we install in the oven. So when the VP is running, other than using the temperature to measure your profile of every board, we are also putting that data out in a video form to monitor.
Okay, understand.
Right. So it's a very visual recording. It's a video recording of the entire VP. Okay, when it's running.
Understand.
Okay. Anyone has any questions? Maybe I'll pause here and see if anyone has any questions.
Anup, Shiva, Sanjay ji, anybody, if any questions?
Okay.
Yeah, I think it's okay.
Okay, I think I will move on then. So okay, I'm at the identify oven temperature. Okay, so let's say when your profile is out of spec. Okay, in your VP, your profile is out of spec. So when you go back to the VP history, right, you can actually see the temperature. Okay, the video recording of the temperature when the profile is out of spec. There's an indication in the footprint. So right now, let's say if your profile is out of spec, you go to troubleshooting, you can see the temperature deviation, but that's the maximum temperature deviation. It does not tell you how long this deviation has been, and it does not show you like maybe is it a 1 second, 2 second thing, or is it a continuous thing? Okay, that occurred from the start of the VP. Okay, so all these data are actually recorded. Okay, you can use it for troubleshooting purposes. Okay, so let's say if you say that sometimes there's an alarm from the RPI, sometimes there's some fluctuation. Okay, especially intermittent alarm. Let's say you have an alarm and then you do not know what's wrong. We do not know what's wrong, especially during like empty oven condition. When you start the VP, right, you do not have any boards that's going in, then it will show you a PWI for the next board. Okay, so at that period of time, if it fluctuates, okay, the footprint is also capturing that fluctuation. So you do not have to worry, you are missing some form of information. Okay, with the
Dennis, I would like to stop you here.
Yep.
Because a question came into my mind. Because the profile is a composition of two data, that is time and temperature. So it is always moving. Whereas if you're talking about probe temperature, it is one-dimensional. So in that case, one-dimensional, and that too for 30 thermocouples. Or if we are not talking about thermocouples, if we are talking about the zones, so maybe depending on 5, 6, 8 zone, whatever it is. So does it give that many plots as per the zones, or how exactly it happens? Because it cannot be similar temperature as the profile moves. It will be something different. Because
correct. It will be not the temperature of the board, is the probe temperature. That means, okay, you can say that we are measuring the temperature in the oven using the probes to measure the temperature in the oven.
No. My question is, see, you have maybe, for example, hypothetically, if in one zone we have 5 thermocouples, so how the plot will move? It will show the 5 plots or 1 plot, or how it is showing how many plots, how many temperature plots it shows?
Okay. If you see from the screen here, right? So this is the footprint. So you can see that these are the thermocouple sensors. So you can see exactly which zone that it's in the probe sensors are at. Okay, so it's plotted according to the zone as well. Right. Prakash, did I answer your question?
I'm sorry. In between, just you started, and in between some call came, and I have to tell them that I'm in a meeting. So can you repeat this again?
Okay, so if you can see over here, right, this is the troubleshooting tab. Okay, so in the troubleshooting tab, we have these are indicators of the thermocouple sensors, and you see there is zone lines, right? So the zone lines actually tell you where the thermocouples are at for each zone.
Okay.
And you can see those gray lines, right? It's where the thermocouples fluctuate. Okay, it's footprint. Okay, where it fluctuates. So when you hover your mouse over the area, right, you can actually see the temperature of the maximum and the minimum. Okay, that it's fluctuating at. Right. Okay, Pankaj.
I understand. Okay.
Right.
So that means if the temperature fluctuation is too much, this curve will be lot of fluctuation.
Right. Let me just show you maybe one. This is a video recording, right, of the temperature that actually fluctuates a lot. Okay. So in this test, right, I actually tried to overload the oven, and the boards that I'm using is quite a high mass. So you can see it's the obvious fluctuation, obvious drop in the temperature. Okay, and then you very fast you will see the alarms coming out from the system. So from here you can see that how long, okay, the alarms occurred, okay, the fluctuation occurred, and then when they resume back. If you notice at the end, it kind of resume back, right? So and then how long did it occur? You know, from the start, you know, as the board goes in, okay, the temperature drops. Okay, then after that, when all the boards exit, right, the temperature kind of go back to the normal state. So this is a test that I have came out with. This is a simulation. Okay. So this is a footprint of a normal condition. Okay, you can see a difference. You know, it's not that much of a fluctuation. You know, like minimal. You can see the probes going down, but it went up again. This is normal because as the board goes by, you know, it drops because the board absorbs the heat, so that the temperature sensor will drop, and then it will go back up because of heat compensation. So it will continue to do this. Okay, but when you overload, then you will see that it drops very fast, and then after that it takes some time before it really goes back up.
Okay.
So this is one scenario that I tried to simulate with the oven over here. Any question thus far?
So far so good. I don't know. If anybody has a question, किसी के पास कुछ हो पूछना हो पूछ सकते हो, क्या दिक्कत है? अनूप, आपको समझ में आ गया पूरा?
जी सर, जी सर, हाँ जी सर,
ठीक है.
Okay.
Yes, okay.
Okay. Anyone here has met with like issues that sometimes the profile out of spec, sometimes it's going well. Then sometimes if you fully load the oven, then you take the baseline, then run the VP. Sometimes it's different from you take the baseline empty oven, then you run the VP. Anyone got this issue?
Yeah, actually, if you remember last time when this footprint idea came to my mind, It was with customer called Interface, and it was a lot of problem when we were, and that too was with two other boards, two similar kind of a board, and because there was no gap, so probably we thought at the final stage that it was 8 zone plus 3 cooling. So final stage, it was becoming like a gas chamber. So temperature was rising too much, and it was not showing onto screen. So that was the idea, and but somehow this problem is solved now. So, but I think it's a good idea to, and this is like a additional feature of RPI now, right?
Right, it's an additional feature of
So
RPI.
you have to buy a license. Customer has to buy a license to get this facility available.
Correct. It will be updated. It will be programmed into the dongle key.
Yeah.
Dongle key of the
and the master key, what we have should work this footprint or not, because we
your
have
your master key should enable this footprint feature.
So you have to enable, right?
No. When you plug in your master key, you will be able to see this footprint tab.
Okay.
Whereas if you plug in the customer's key, they should not be able to see this footprint tab unless they buy the feature.
But our master key is quite old, so still it will show that.
Right, it will still show that.
Okay.
You have you tried it?
No, I never till now, never. But we have downloaded new software at that same customer interface. So whenever we get a time, a week or maybe after a week, so we'll try there, and then we can record something and can show them if it is happening.
Okay, please try and let me know if you face any issue with the key. I think we can do some updates to the key, or if you can, do you know how to export the key file?
We did few years ago, but okay, we can learn. And another thing is, Dennis, we have many service engineers and who are doing working. So is it possible if you can give at least 2-3 master keys so that they can go and because every time we send key 1 or 2 keys, we have in fact 2 keys. So it is difficult to manage between 5 offices. So if you can give me 2 more, that will be more efficient for us to work.
1 key for each office, you're saying?
Yeah, minimum at least. And we don't need any keys. You can just we have sufficient dongle keys because sometime customer has this server keys which is lying anywhere, so we can borrow with them and you can reprogram it. So need not to send the keys. Only thing is you need to program it. That's all.
Yeah. Okay, Ken. Let me. I'll talk to Lu because the key is software key is under him. So I'll talk to him and see if I can arrange the extra master key for you.
Okay.
Then I'll keep you posted.
Okay.
Is it okay?
Yeah, it's okay.
Yep. Okay, so I think this feature so far it's very good, not only for the customer but also on our end, because let's say we want to do any troubleshooting, right? We want to find out whether is it the issue coming from the system, or is it there's some intermittent issue that's coming from the oven. We can also use this feature to do so. Okay, because let's say if the profile is out of spec, we see the troubleshooting, we only see the maximum, the maximum deviation, but we do not know how long. It's like taking a picture against taking a video. A video will show you more things compared to an image. Yeah. So that is the purpose of the footprint itself. Okay, so instead of just a picture, we are going to show you the video. So the concept is very similar to like using a profiler. So when you use the profiler, you only know the condition at that point of time, and then you use the automatic system because you want to monitor the entire condition. So for the troubleshooting, we feel that it's just a fixed image. So we want to have this footprint, okay, to complement the entire monitoring system.
And which version of KIC RPI software has this footprint?
From the latest version, right now in the RPI is 3900. That's in the website right now. From that version onwards, we will have the footprint.
Okay.
Right. In future, all the release will all have this footprint.
So in case if we want to show customer a demo, we just upgrade their software, use our master key and show the demo. And if customer is interested, they can buy that.
Correct. Upgrade the feature, upgrade the software, and then after that, use your key. And then yeah.
In that case, you will be sending the new dongle, or you will be just upgrading the software.
You just upgrade the software. I just need you to.
The problem in India is, I don't know, but what I understand is it is very, very difficult to sell this option if we are not getting anything physically in India. They cannot make a payment. If you just upgrade the software, government will not allow, a bank will not allow to make the payment.
You need to have something physical.
Something physical.
I think if in that case we can do dongle. If you need, we can do dongle key.
Okay.
That means to issue another dongle key for them, but it might not be so practical to do that unless maybe we can.
Then customer will have two keys, so that is also a problem for you.
Right. Usually for software, I'm not sure in India how do you handle?
We can check, but it is something very difficult because we tried that. I don't know whether you was there or not when we were implementing Napino, the iTech software. So the bank was not allowing. So in that case, the physical key was sent, and then only the payment was done.
Okay.
Or maybe you can send just a pen drive with some software, and we'll see what is the possibility. If you don't want to send the dongle, at least the pen drive.
Can we do that? Yeah, maybe we send a pen drive with the maybe the RPI software inside, the latest one, and then after that we do the upgrade through online. Just the pen drive to get the payment.
Yeah. Okay.
Is it okay? Because the upgrade of the software is, we can count that as part of the Probo upgrade. We can do that.
Okay.
So that is for let's say you want to do an upgrade on the existing one. I think, but for new one, it shouldn't be an issue, right?
No,
all the new system. It's because there's hardware going over.
So it means in the new quotations, we must quote RPI and as an option footprint.
Right.
Okay. And the cost of the footprint is $975, I think.
Correct.
Okay.
Correct.
And there is no bundle price for RPI and footprint together?
Right now, no, because we released this feature, and then it will be an independent feature for now.
Okay.
So it will be an add-on for the future, because right now we released this new feature, right? And then all the existing one we would want to do an upgrade, because if we put as a standard, then there will be no upgrade involved. So maybe I think you can try. I think we maybe for your info, we got orders from JBL in Penang for this feature. They are going to do it as a trial, so to test on their NPI line first. So once it's approved, then it will be in the rest of the lines in the factory.
Okay. And for RPI, one footprint, and for the dual RPI, two footprints.
Right.
Okay.
It will be the same, and then you have front and back both these footprints.
Okay. And how many? This is just a different question. How many 24/7? Not the WPI. How many WPI has been installed so far?
In JBL?
Anywhere.
JBL. Okay, JBL in Penang we have 6, and we are starting to install in Delta in China. That's right now it's installed about 3 systems, and then they actually ordered 20. So 3 is installed, and then we're going to progressively schedule the rest of the install. Recently, we installed one more in Samina, right in Thailand. That one we're going to do an eval soon, okay, for that system. And then upcoming, we have one more in discussion is with Celestica.
Okay. And at Jabil, which oven you have installed WPA? Which wave?
Electrovert EC4.
Okay. Okay.
Electrovert EC4.
And all Electrovert EC4?
We have EC4. We installed in I think Samina is Vectra.
Not the Samina. I'm talking about the Jabil only.
Jabil only EC4.
All.
Yeah, all 6 on EC4.
Okay. Because this is very, very easy, or maybe more convenient for us to convince if Penang is implementing, and I need to check which wave. I don't remember the wave name, but I think it's Electrovert only. So we need to check.
Do you need a report? I have a BIOS report.
Yeah, then it will be much, much easier.
Okay, I can send it to you. This exact report, right? It's not done by me, but it's done by one of the distributor that sell the system into JBuild, and then they did this eval together with JBuild, and then after that, we sent this report to JBuild for the system to be approved.
Okay.
So I'll send the exact report to you.
Okay.
Then maybe you can use it with JBuild.
All right. So anything left in this footprint? I think it's done. This is pretty straightforward.
Okay. Nothing much. Okay. Basically, over here it just shows you the recordings. Okay, and then you see red lines in the timeline. Okay, that is indications of PWI that's more than 100%. So what you can do is you can actually navigate to the place, and then you click on play, and you can view the recordings. And then you can also hover to individual boards. Okay, in the charts you can actually drag this. Okay, and then able to monitor the footprint. So that's all. Okay, actually for the footprint option.
Understand.
Anyone has any questions?
Prakhar, Anup, Sanjay ji, Dipanshu, Ajay, Shiva, Swami.
Pankaj ji.
Any questions about this?
No, actually, this is mainly applicable for Probot RPA, this system.
Yes.
Not only
Right.
RPA, we can discuss with Continental also.
Correct. Probot RPI. This is very good for, let's say you have existing customer base that is already using Probot RPI, right? With the master key, you can easily do a demo. So you can go everywhere to do this kind of demo, and then just show to them, and then after that, see whether they are interested to do an upgrade for that.
Yes.
Sure.
Right. Especially, I think for Mectronics so far, I think your automatic system customer base is very big in India. So I can just you just count how many systems there in India, and then after that, you count, you multiply by the amount. Right. So I think it's a big, quite a substantial revenue that you can get from there. And this is not a lot of work for the option to be upgraded.
Exactly. No, we'll do that. We'll try for this. This is good idea, good option. Right, Dennis, if you have any other news on any other product, maybe you can just share, and otherwise we can close this meeting. Because
okay, something else that we recently have. I'm not sure. Do you have vacuum reflow in India?
I have seen only one, not many, but I've seen at least one.
At least one. Okay, so I think we are starting to move into a system for the vacuum reflow oven. So maybe let me just show you, give you some context. So you know, vacuum reflow, I think recently now it's become quite popular, and in our region, especially nearby to us in the Southeast Asia, we actually see more and more factories starting to talk about the vacuum reflow, and then expressing interest on this vacuum reflow oven. So over in the Europe, right? Actually, it's already a trend. That means it's going on. A lot of ovens, right? It's with the vacuum section, okay, in the reflow oven. Okay, so I'm not sure whether would this trend be coming to India soon? Probably it will be coming, because I think several customers also do some tests on the vacuum reflow, right? And then actually they actually found that the void is significantly lower than 2%. So this is why I heard from most of the customer. Okay, so we are creating a system, the RPI system for vacuum oven. Okay, so the concept of vacuum, right? Okay, I'll quickly go through this. So why does manufacturers implement vacuum reflow, right? Okay, it's to minimize the void, okay, to be less than 2%. So we can compare, okay, with no vacuum and with vacuum, okay, the voids are actually significantly reduced. And then the control factors, okay, actually for the reflow oven is the preheat, okay, the vacuum temp, and also the cooling section. Okay, so how do we ensure, okay, that the profile is in spec, okay, for every board, okay, in the vacuum reflow? So it's similar to the reflow oven. Okay, we use the RPI system. Okay, so previously our RPI system is not able to install in the vacuum oven. Okay, particularly because we cannot measure, okay, the temperature in the vacuum chamber. So we did some modification, and we come out with some parts, some hardwares, okay, to measure, okay, the vacuum chamber. So we implement RPI vacuum system, okay, to get insights and also get profile data, okay, from the vacuum reflow. So the main results that we want to measure is the vacuum process. Okay, apart from the preheat and the cooling set, we want to get measurements, okay, of the vacuum process. So at the moment, right, we are actually compatible with RIM. Okay, we have developed system for RIM oven, SMT oven, and Ursa oven. I'm not sure. Pankaj, is these three brands how to say, popular?
All three are popular in India.
Popular in India?
Yeah.
Right. So the vacuum oven that you see is belong to which brand?
Actually, that was not my interest, so I did not
okay.
get any focus on it, but I don't remember what was it.
Okay. Maybe you can, I'm not sure, maybe you can evaluate the market. Yeah, and see if there's any of these brands in the market, okay, that your users are using, okay, vacuum, and then whether are they interested to install the system. Okay, so how we install, right? Okay, this is the board sensor, right? Board sensor is at the front, and then we have kick probes, okay, that's going through the heating segment. Okay, this is the similar concept like our RPI for the reflow. And then we have a TC extension, okay, that's coming out from the connector, right? And then we put it into the vacuum zone. Okay, this is where we measure the vacuum, the temperature in the vacuum chamber. And then lastly, we have the probes, okay, to continue for the cooling zone. Okay, so this is how the system is being installed, okay, for vacuum ovens. Okay, so from the profile, right, we can actually see, okay, the usual profile graph, and then we can see the time in the chamber, and also the graph, you can see the temperature, okay, in the chamber. So there are two things that we can get out of from the system. One is the temperature and one is the time. How long has it been in the chamber? So I've covered the temperature, right? Just now we put the thermocouples into the chamber. So next I'm going to cover how do we get the time. Okay, so we put thermocouples to get the temperature, and then we get the signal. Okay, for vacuum chamber, right, there is actually board sensors, okay, before or inside, either outside of the chamber or inside of chamber, depending which brand are we talking about. So we get the signal of the board sensor, okay, that at the entrance, okay, to detect the board. Okay, and then we know that the timing that the board enters into the chamber, and then we get the signal of the board sensor at the exit. So we know that how long, okay, the board is in the chamber. Okay, so we do that for the rim oven. Okay, any questions so far? Maybe I
Yes,
forgot
I
to
have.
stop.
I
Yeah,
have.
please go
So
ahead.
that means when you're talking about the vacuum ovens, you have two additional sensors beside the normal board sensor. You have one.
This is from the oven.
Okay.
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 This is present in the oven
Okay. So these.
already.
Okay. So you use the data of this.
Correct. We use an optocoupler.
Okay.
Optocoupler to tap on the signal of the board sensor. That means to say, we tap into the circuit, the schematic of the board sensor, and then we get the data. We get the signal of the board sensor from there.
Understand.
Right.
And if you can go one slide back.
Right.
No, further back.
Further back.
One more. Yeah, this one. So
Okay.
in the hardware section, so where there is a vacuum zone, there is no TC, just this 24, which is going externally out.
Right. It's going into the chamber. It's inside the chamber.
Inside the chamber. Yeah. So that means we have to measure the O1 very precisely. So there is no sensors in the vacuum zone, but there will be additional external vacuum TC, which will be in the vacuum zone.
Right.
Area.
Right. We need to install the TCs into the vacuum chamber.
Okay.
Right. Don't worry, we have the instruction on how to install, how to route the thermocouples into the chamber. So this is not a fully new system. So far, it has been installed in systems in the Europe side. And over here, we are also starting to install. We have already installed in Delta in Thailand, and also we have installed in the SMT also in China. And upcoming, we're going to install one more in Ursa.
Okay.
Okay, that's for Asia. And for the Europe side, it's constantly going. It has been, I think, more than 10 for them.
Okay, and one more question.
Yep.
So this the TC which is going into vacuum area, is it a different TC or it's a K type or?
It's a K type.
K type. So why do you need this external?
Why we need this to be external? Or you mean to not follow this?
Yes.
Because the chamber will close.
Okay.
The chamber will close. It's like a box you see here, right? It's a box. So it will go up and it will close. So if we lay the probes across, right, it will be getting in the way of the vacuum.
Okay.
So we need to have one TCs to go in and then place it here.
So you mean to say that means I need to rephrase again. So you mean to say the TC until 23rd and until 22nd, it is one probe, and then again new probe is starting from 25th and 26th.
Right. So the probes, you can see it's okay for the odd probes, right? It's two sections.
Yes.
Okay, one is the heating and one is the cooling. Okay, that's for the odd probes. For the even probes, we have the probes for heating, one for vacuum, and the last one is for cooling. Okay, this line is from odd. Right.
So question remains same. Question remains same. So that means it is terminating at number 23 and number 22, or it is further going to 25 and 26.
No, it's terminating there.
Terminating there. Okay.
Right.
Okay.
It's terminating there.
Okay.
So we installed, the conventional probes, we install it one way and then we lock it at the back, right? So this probe, we're going to go in and then lock it here. And then from the back, right, we're going to put the sensor in and then lock it here.
Understand. No, understand. I understand.
Right. Okay. And then this is totally, it will be a external, it will be a independent sensor.
No, I got the complete idea. Yeah.
Right. So this connector, don't worry, it's already, it's already split. You have this three sensor that's coming out. So you just need to install as per the configuration.
Okay. Okay. Understand.
Right. Okay. So this is for rim, right? This is rim. And then this is SMT. Okay, if you ever have SMT vacuum oven, right? It's a lot more easier because for SMT, we do not tap on the board sensor signal through hardware. That means we do not use the autocoupler, but we use oven communication to communicate with the software, and then we get the signal through that. So we do not have to install more hardware compared to the URSA or the RIM. This is for SMT.
Okay, understand.
Okay. Then for the URSA, it's the same. We install the probes, okay, in the chamber, and then we use the autocoupler to tap on the signal.
Okay.
Okay. So this is a sample. Okay, this is a baseline. Okay, baseline, and then we see the VP, right? Let's say that this is we tested under normal condition. Okay, the vacuum timing is 55, and then the baseline is 58. So we did another test. We reduced the vacuum timing. So we try to see if it reflects in the profile. So this is the results. So 32 seconds. So we're able to detect, okay, based on the board sensor signal. Okay, so the rest is actually the software option, the software feature option. Okay, so I will not go through that because that's the same as the RPI, like all the charts. So I think everyone knows all the features inside. Okay, so maybe let me just say how much the system, right? How much revenue you can make from the system. So this system, vacuum reflow is actually almost double the pricing of the oven, double or triple, okay, of a normal reflow oven. So our system, similarly, it will be about double or triple, okay, the pricing of normal RPI. So the profits there, it's also double or triple. So when you sell a system, it's like selling 2 or 3 RPI, okay, for vacuum.
Got it.
Right. So that is the revenue potential that we are seeing here. So, and then we are actually seeing a lot of manufacturers are starting to look into investing into vacuum reflow. So whenever you have a vacuum reflow, you see a vacuum reflow, we can try to approach them because I think for budget wise, if they will be able to get the vacuum reflow, because the reflow itself is already costing quite a lot. So right now we are seeing like mostly tier one customers. Those are leading manufacturers are starting to implement that. So maybe you might keep a lookout. In back to JBuild in Penang, right? Penang, we are also looking to install into a rim. And the SMT and the URSA oven that we installed in China, it belongs to JBuild also.
Okay.
Right. So I'm not sure whether in in India there is a lot. I think do JBL in India manufacture for Tesla?
So far, no.
No? Okay. Okay, I think this project is for Tesla. I'm not sure. Maybe you can evaluate your market and see whether you have any vacuum reflow.
Now we'll look for that, but I don't think I have just only one, so I don't know.
Okay, yeah, just sharing with you. This is something new that we are working on right now because we see a trend over here. Then anything else? I think WPI is everyone familiar.
Actually not. I have some knowledge. In fact, I presented 2 times, so I have a little bit knowledge. But if you want to share, that would be a nice idea.
Okay, let me just share with you. WPI we have. Okay, WPI is the RPI, right? The full option, right? And then we also come out with like a probot for WPI. So it's called WPI Essential. So the price is slightly higher than probot because of the hardware. We have more hardwares in the WPI. So, but it's a substantially lower pricing than the WPI. So let's say if you have some customers that is using probot or has some budget, then maybe you can go for the WPI. We call it WPI Essential. So we it's a probot version of the WPI.
And mainly, I want to understand on the WPI, how do you do the dual timing? Because earlier it was not the feature in 24/7. So I know a little bit, but how exactly you do this? That is my question.
Right. Okay, let me just explain it to you using the sensor map, right? Okay, so I think the board sensor and the kick probes, it works like the reflow oven. Okay, like the RPI system. So I'll not go through this part. So how do we measure the solder, the solder temp and also the contact time, right? So okay, over here we install the solder port TC, okay, into the solder port, okay, to measure the temperature of the solder. Okay, so when we get the temperature of solder, we know whether is the solder hot enough, not too hot, or what is the temperature of the solder. And then at the exit, we install the pyrometer. Okay, pyrometer is like a sensor that is detecting reading the temperature of the surface.
Yes.
Okay, it measures. And then we have an exit TC sensor. It's exit TC sensors is actually kick probe sensors. Okay, where we measure the temperature where it is outside. Okay, where it's coming off from the port, right? So the function of this is similar to the kick probe, but it's just at the end. So if you how should I bring it? It's like the concept of the vacuum. So we have an exit TC here because we cannot lay the kick probes all the way. We do not lay the kick probes all the way, so we put an exit TC. Okay, at the exit. So the main thing to measure contact time and also the temperature of the contact is a combination of the port TC, the pyrometer, and the exit TC. So the port TC is actually there to measure that ensure that the solder is at the right temperature. Okay, so that's its only purpose. The exit TC is performing the same function as the kick probes. So what is important is this pyrometer. So pyrometer is reading the temperature of the surface, right? So how do we put that into time? Okay, so when your pellet is going through the solder, right? When it goes through longer than usual, the temperature will be higher than usual. So when it goes through faster than usual, then the temperature will be lower than usual. So we read this temperature from the pyrometer, and then we have the encoder, right? We're able to get the timing of the fingers. okay, the conveyor. So together with that, we are able to get the contact time of the pellet itself. So the concept, okay, of the dwell time, right, is by reading the temperature, okay, and then understand from the temperature how long is the time, okay, because we contact the solder longer, the pellet, the temperature on the board itself will be higher, okay, than it should be. Okay, if it's not contacting, is contacting lesser, okay, then the temperature will be lower because the solder did not touch, right? Or the solder touched very quickly that it did not hit the board up, okay, to the temperature that under normal condition.
Okay, I understand your answer, but this pyrometer is installed close to the pot, or it's as it shows, it's just at the exit of the conveyor.
It's at the exit. Let me just show you some, maybe
By the
some.
time, okay.
Oops. Maybe a good one. It's at the exit. Can you see this big,
Yes.
this big tube here? This is the pyrometer.
Okay.
And then in front, actually in front of it is the solder port.
Mm.
Okay.
So ideally, if it is much closer to pot, it will be reflecting more accurate temperature.
It will not be exactly above the port, but it will be somewhere after the port.
After the pot, okay.
Right, after the port.
And
actually, we do not worry much about, as long as you know the temperature does not go too low. I think the temperature out from here, from the top surface we measure, is still about more than 100, usually more than 100, 120 or so. So because we take the baseline, right? We take the baseline, we need to reference to the baseline as well.
yeah,
So let's say when your baseline, you take the temperature, it comes out is 120, and then your VP comes out from the parameter, it reads like 100 degree. Okay, we can determine that, you know, there's a difference in the temperature there.
I understand.
Right.
And secondly, when you're doing this installation, if this pyrometer angle changes after BP, then also the temperature, this correlation will be different.
Pyrometer temperature change,
because it is it's an angle. If it's angle, little bit slight in angle. Yeah, if you're talking about this, so if this angle changes, the temperature will change, or doesn't make any difference.
if the angle change, no, you mean during the installation, when you install
after the installation and after the BP.
After the installation, after the VP, you will not be adjusting the pyrometer. It's installed in the fixed position.
Anyways,
so
okay.
You mean the this is fixed on a fixed angle?
Okay, anyways, this is a practical thing. This is not a very critical. Okay, I understand.
Right. This report is from JBL. I kind of blank out. So this is on the EC4. Okay. This is the installation that we have done. This is actually
just go up a little bit. There was a sense. Yeah. What is this?
This
yellow one. Next one.
Board sensor.
Board sensor. Okay.
Right.
Okay. Normal board sensor. Okay.
Right. So this is the click probe, and then encoder. The port TC, then the pyrometer sensor. This is the palette that JBL is using.
Yeah.
And you use the X5. Then what they did is that they run a test, 25 in total. So they kind of monitor its consistency. And then at the end, they actually write off that they passed the test. I can send you a copy of this. Let me just check with if there's any issue that this can be shared to you, and then I can share you a copy of this, maybe with the information.
Okay.
How many wave do you have in JBL in India?
I don't remember, but I think it's more than 6, 7. I don't remember.
Okay. Okay, maybe we can try in India, JBL India. I think it's EC4. Is it EC4?
Yeah.
Yeah, I think we can try. You can try and see if they will be interested.
Yeah, Penang. If Penang has the installations, so there is quite a chance that they can go for it.
Right. Penang has already installed the system.
Yeah.
And you see, this is from JBL in China. This is also EC4. This is JBL in Guangzhou. Same thing. Right? The port TC. This is the light bar. Where they put the TPUs. So I think quite a chance. Now Penang is installed, China is also installed. I think maybe you have some chance in India.
सही वाला करो विशाली से बात करके देता हूँ Yeah. And this eTPU in this WPI is a similar kind of as RPI or is a different WPI?
It's the same eTPU as the RPI.
Okay.
Okay, below are all the settings. Anyone has any questions? Maybe.
I think this is first-hand knowledge for them for WPI. So the question will come when they go into the field and customer bang the questions. But I think it's a good information for all. They must have seen all those connections, etc. So it is
right. I think when
so
let's
Dennis,
say if you
one question.
Sure.
Actually, one system is there in Schneider. They bought nearly 5 years back. They were not using this WPI. Can we implement this pyrometer into that?
You mean there's a 24/7 there?
Yes, 24.
Yes.
We can do an upgrade on the system. Correct. How what's the condition of the system so far?
No, they rejected it and they're not using it at all.
It's in where?
It is in Schneider, Bangalore.
Schneider? Okay.
Yes.
Maybe can you get me some information, like how is the condition of the system so far, and what maybe you give me some information, and then I will advise you what we can do to upgrade the system into a WPI.
Shiva,
Yeah,
today
I'll
I think
I'll check with
Schneider. Shiva?
Yeah. I will check with
So you please take photos also. What are the things installed? Take a small video.
Sure.
So that will be much easier for him to understand.
Right.
Yeah.
Schneider is what wave machine? Which brand?
That is Ersa only.
Ursa?
Ersa, yes.
Okay. Ursa, which model do you know? Maybe you get some.
That information I'll get for you.
Because this is by chance he is in Schneider only today. He's in Schneider, so he can do that. He's doing one installation of RPI, so he can take photos of this 24/7.
Okay. Help me to take some photos, and then maybe send it to me, and then I will let you know maybe what we can do to make it into a WPI. Did they reject that?
I will get the information.
Did they reject the system because there's no wave? What's the reason? What's the reason that they rejected the 24/7?
I think it was not. See, first of all, 24/7 was giving only a preheat data, so that was the idea, and that was not enough for them. So if it goes to WPI, it will give wave data as well. So then it is a complete system as wave profile comes.
Okay. I think if that's the reason that they have, that they reject the 24/7, then maybe we have some chance.
Yeah, we don't have any option to take the contact time with the 24/7.
Right. Right. We can do that
So
with
there is a limit
WPI.
and yes. Okay, we'll get the information.
Okay. Yeah, please. Thank you.
And this system was installed by KSLU 5-6 years ago. It was installed by KSLU because it was the first system of India. So he came here to install.
Okay.
Schneider.
Okay. Let's see. Let's get some details and see how is the system, what's the condition, and see what we can do.
So probably KSLU must have all these photos, but he will also gather. But probably KSLU will have all those things available with him.
Okay. I can get the information from him, but that is maybe 5-6 years ago. Maybe we can see what's the condition now. Not sure.
He can gather all those information, Shiva.
Okay.
I think, Dennis, thank you very much. It was a very beautiful meeting today, and we learned a lot.
Right.
So,
thank you, everyone.
This kind of interaction will give more knowledge to our people and to us.
Sure. I think let me know if you have any questions. I think we have been receiving constant support from your side. I think it's been many years that Mectronics has supported us. So I hope that we can continue to work with Mectronics, and please feedback me if you have any insights or any suggestions that you can share with me in the market. So we can also learn from there, and also if there's any needs and demands, we can also work together.
Yeah, sure.